Hello and welcome. In this session, we'll explore stationarity and how to test it using the Augmented Dickey-Fuller or ADF test. Understanding stationarity is crucial for accurate forecasting and modeling. Let's dive in. Stationarity means that the statistical properties, such as the mean and variance, remain constant over time. The ADF test is designed to check whether a time series is stationary. This test helps identify the presence of unit roots, which indicate non-stationarity. A stationary time series simplifies analysis, making predictions more reliable. Now let's understand the hypothesis framework of the ADF test. The null hypothesis, or H0, assumes that the dataset has a unit root, meaning it is non-stationary. On the other hand, the alternative hypothesis, or H1, suggests that the series is stationary. To test this, we apply statistical methods, evaluate the null hypothesis, and make decisions based on the p-value. If the p-value is low enough, we reject the null hypothesis, concluding that the data is stationary. Speaking of the p-value, it plays a crucial role in interpreting ADF results. The p-value tells us the probability of observing the results under the assumption that the null hypothesis is true. A p-value below 0.05 suggests strong evidence against the null hypothesis, supporting the claim that the data is stationary. Alongside the p-value, test statistics are calculated to assess whether the null hypothesis should be rejected or not. Let's see how this test can be implemented in Python. The Stats Models library provides a simple way to conduct the ADF test. The test yields a test statistic and a p-value. If the p-value is low, typically below 0.05, we conclude that the data is stationary. This step is crucial in time series analysis, as many statistical models require stationarity to provide accurate forecasts. Visualizing these results helps us make well-informed decisions for further analysis. Besides the ADF test, there are other methods to check for stationarity. The KPSS test determines if a time series is stationary around a deterministic trend, helping us understand if the data fluctuates around a constant mean or follows a trend. The Phillips parent test also checks for stationarity by identifying unit roots. Both tests play an essential role in ensuring the accuracy of time series models. Analysts rely on these tests to prepare data effectively, ensuring that trends or non-stationarity do not mislead the results. While using the ADF test, it's important to avoid common mistakes. Misinterpreting the test results can lead to incorrect conclusions about the data. It's crucial to correctly interpret the p-value, as it helps determine whether the data is stationary. Additionally, failing to consider sample size can affect the test's reliability. Another common oversight is ignoring outliers, which can skew the results and lead to inaccurate interpretations. That brings us to the end of this session. I hope this explanation helped you understand the ADF test and its importance in time series analysis. Thank you for joining, and if you have any questions, feel free to reach out. See you in the next session.